Network programming is used to program and virtualize the network. We're talking about protocols, programming, scripting, data modeling, and markup languages, as well as architectures and APIs, or application programming interfaces. Protocols like the OpenFlow protocol, which allows a programming language to control the forwarding plane of a switch or a router, as well as netconf and restconf. Programming languages like C, C++, and Java, scripting languages like Python, Ruby, and Lua, data modeling languages like Yang, markup languages XML, and architectures and APIs like the REST architecture and API used over a web browser, and the Java API with all of its libraries and pre-written classes and blocks of code. SDN, or software-defined networking, is an approach to networking where the network is software programmable remotely. It involves the Open Network Foundation, which supports the concept and the development of SDN, and has also been responsible for releasing the OpenFlow protocol or standard, which is a protocol that separates the control plane from the forwarding plane in switches and routers. Also listed here is Openstack, which is a software platform for cloud computing and providing IaaS, or infrastructure as a service, which means the ability to manage pools of processing power, virtualized servers, and network storage on an as-needed basis for the customer through a data center. In this image, you can see a comparison between a traditional architecture and an SDN architecture. Notice how in the traditional architecture, each device, device 1, device 2, and device 3, let's say they're network switches, each device has a control plane and a data plane. And so to configure those devices, you configure the control plane on each of those devices. In an SDN, or software-defined networking architecture, notice how the control plane has been separated from the data plane, and now the three devices, let's say there are three switches, could be controlled from a single control plane or from a single controller using the OpenFlow protocol. This way, the three switches can be programmed from a single point or a single software program. In this image, you can see this example further. In this case, the application has been developed using Cisco's 1PK Open Network Environment Platform Kit, and the software has been written in, let's say, the C or Java or Python programming languages, and the application can program the data plane on the three switches, device 1, device 2, device 3, using the OpenFlow standard. Network controllers are SDN control plane devices, which are a programmable point of automation to manage, configure, monitor, and troubleshoot virtual and physical network infrastructures. This automates the configuration of the network infrastructure. A network controller is a hardware device which locates the SDN control plane. An example of a network controller used in SDN, or software-defined networking, might be the Open Daylight platform. The Open Daylight platform is an open source SDN controller platform. You can see in this example where the SDN controller works with an application to then control the network devices, here listed as device 1, 2, and 3 at the data plane. The Cisco ACI, or application-centric infrastructure, is Cisco's approach to software-defined networking and network controllers. It involves three main things: an ANP, or application network policy, an APIC, application policy infrastructure controller, in this case the APEC EM, which is the enterprise module for APIC, and switches that are application programmable, like the Nexus 9000 series switches. In this example, we can see how the Cisco APEC EM works. The APEC EM, or enterprise module, is the SDN controller which sits between the application and policy and the data plane devices, device 1, 2, and 3.